Hello, welcome to Devoxx 2018. I'm here with Alex Rickabaugh from Google. He works on the Ivy compiler, among other things, but mainly a compiler, I think.
Yeah.
Welcome.
Thank you very much. Great to be here.
So you work on the compiler, right?
I work on the Angular compiler, yes.
How's that, being a compiler writer in JavaScript as well?
It's a lot of fun. It's kind of a strange world because it's a transpiler, not a compiler. So it's you're converting from one source format to another. And we're actually built on top of the TypeScript compiler. So we're essentially a plugin to TypeScript, some transformations that happen during TypeScript's compilation pipeline.
And is this like a preprocessor or something, or do you actually hook into the abstract syntax tree of TypeScript? Or?
There's a little bit of both, actually. So we work in two phases. The first phase is called analysis. That happens before TypeScript does much of anything.
Yeah.
TypeScript has already processed the AST. It's figured out what the types of everything are. It knows whether the program is correct by its standards. But we still have to check whether the program is correct by Angular standards. So we enumerate all of the ng modules, all of the components, make sure that you're not putting a component where a pipe is supposed to be or something like that. And then we extract all the information we need to compile the Angular side of the program. And then TypeScript goes and does its emit phase where it's trying to produce JavaScript code for every single file in your program. And we hook into the AST there and start kind of attaching things on for Ivy.
And then you hook into like also the tree shaking part, I suppose, because the TypeScript does the main compilation. So apparently there's stuff there that you don't need.
Yes. So TypeScript is its job is to transpile the program as you wrote it. It doesn't quite understand how it's going to be used in the larger picture of the application.
Yeah, because it's generic.
Yeah, you might be calling transpiling a library for Angular, and so you compile a dozen components, and only 2 of them are actually going to be used at runtime. So we do a few things there. Ivy in particular is designed to be tree shaken.
Yeah.
So the structures of the code that we emit is really optimized so that the tree shaker can glean the maximum amount of information from it. The tree shaker wants to be able to know what's referencing what and be able to prove that if you don't use a particular instruction, it can remove it.
Yeah, so basically I suppose you need to do that to make a lot of things static, right? Statically referenceable.
Yes, exactly.
No map lookups and stuff like that.
One thing our compiler does, for example, is if you have an ng module really declares the scope of the template for a component.
Yeah.
And what that means is if you have other components or directives that you reference in your template, the component's ng module tells you how to figure out what those are actually going to be at runtime. So if I'm using material button in my template, I need material button imported into my ng module. But unfortunately, that reference is actually the wrong way around for tree shaking. The module refers to the components. The components do not refer to the things that they use. And so we actually fix that in the Ivy compiler. When we compile a component, we emit a directives array for it that tells you exactly what directives are used in that component at runtime.
Yeah, so you can just see it at a glance, basically.
And the tree shaker can too. And so the tree shaker knows that if something's not referenced by a component, it doesn't.
Yeah, it just throws it out. Yeah.
Exactly.
And you do that like in a multi-step process or something, like going down the tree, up the tree all the time, seeing things are unused. And
so that analysis phase that I was talking about at the beginning, we build a graph of all of the ng modules, components, directives, pipes.
Yeah.
And then when we're compiling an individual class, we have all the information we need collected ahead of time to enumerate exactly what's going to be used.
Ah, okay, yeah. And that's all hidden for the developer, I suppose.
Exactly.
If we go to Ivy when it's released, I'm not going to ask when that will be. Silly question, I suppose. Do I have to do stuff? I mean, upgrade, I suppose, but after that?
It should be a drop-in replacement for the vast majority of applications. As long as you're not kind of in weird corners of our API where you're depending unintentionally on specific behavior of ViewEngine, then yeah, you should just be able to flip a flag and try it out.
Yeah, and so like a normally CLI generated app with no custom Webpack things should just work.
The biggest challenge is we have to bring libraries in the ecosystem along with us. So our promise on the compiler is that if you have a library built with Angular version, let's say 7, you can depend on a library built with Angular version 6 and published on NPM.
Yeah.
So anytime a major release comes out, you don't have to wait for the entire ecosystem to upgrade to it before you can use libraries that are already published, presuming they're kept up to date reasonably quickly. And with Ivy, that becomes a challenge because the output of the compiler is very different.
Yeah, and the framework expects something from that
Exactly.
output.
And so we have a tool called the Angular Compatibility Compiler, or NGCC.
Yeah.
And you run that, and what it does is take your node modules and give you a set of your dependencies that have been upgraded to work with Ivy.
Okay, so you can have like this hybrid mode or something.
Yes, so instead of compiling, if your library is built from TypeScript with Ivy, that's great. But if it's built with an older version of Angular and published to NPM for View Engine, NGCC will actually compile that and turn it into an Ivy library.
Yeah, like at build time, your build time.
Yes, exactly.
Awesome. And like being a transpiler guy, there's a lot of big brains here as well on the Java compiler. Do you see things like how that can influence each other? Because this stuff is getting way more advanced, like very quickly, I think.
There's a lot of the theory that overlaps, especially in the case of type checking and some of the more kind of the theoretical algorithms that we use for compilation.
Inlining and stuff like that.
Yes, exactly. It's a lot on the optimization side that we're just starting to look into.
Yeah, yeah.
Ivy opens up some interesting opportunities for us as far as optimizing and being able to do more steps in the compiler to speed up applications. Right now we're just trying to get out the door, but we'll definitely be looking into those things.
Yeah, yeah. But I suppose it will be a different beast than a Java compiler, right? Because it outputs to a different kind of environment.
So a Java compiler's main goal is to generate highly efficient code at runtime, right? So Java compiler is trying to compile to bytecode. It can do a lot of optimizations there. It's not really constrained by how much bytecode it emits.
Yeah.
It's okay if your jar files are several hundred megabytes.
Yeah, it's a local file system and it's lazily loaded and stuff.
That happens quite often. Our Ivy compiler has a very different goal. It wants to generate very minimal templates because we have to send those over the wire to clients. And clients are always, they're almost always on like mobile connections or Wi-Fi.
Yep. Slow devices.
It's rare that people have, hardwired fiber connections to a data center.
Yeah, and I suppose like the bootstrapping of the compiler and all that stuff is also like blocking code, so you also want that to be
Exactly,
quick.
yes.
Is Ivy also better in that? I mean, 200K takes longer than 2K to parse, so that's a good thing, I suppose.
Yes, and in particular with the way Angular worked before with JIT, when you compiled an Angular application in JIT mode, the compile happened in the browser, and it had to compile all of the libraries that you were depending on as well. So if you're using Material in JIT, you have to download the entire Material code base on top of the compiler.
Yeah.
Run it through the compiler, which is seconds of blocking script time while your application is kind of hanging there, the user's waiting for it. And then the JIT compiler will compile your app and boot up. And Ivy improves that significantly.
And hopefully you don't need the JIT anymore then, or
yes.
Is that too much?
Well, it helps in a couple cases. It helps at development time because when you're running just ng-serve in the CLI, for example, you're running JIT. You're actually, your edit, save, refresh cycle is using JIT. And so that actually can be made much faster because you don't have to do all the work of compiling all the libraries.
And maybe you can even get rid of the AOT options then, because it can be a default, because it's so fast you don't need anything else.
I wish that were true. We still have to ship the compiler to the browser, so AOT is still a very important optimization there.
Yep.
It's the difference between a couple 100K bundles and a couple kilobytes of bundles. Our Hello World now for Ivy is 4.5.
Yep.
And we think we can actually optimize it a little bit more.
Cool, and do you also, because you compile a lot, if you have a lot of dependencies, do you also benefit from that tree shaking part?
Oh yes, yeah, absolutely.
So if I package, just name a big library, they will also be tree shaken better than before.
One of the points I tried to make in my talk yesterday is that it's really on library authors to design their libraries in a way that will interact well with the tree shaker. It's very easy to get into some of these patterns where you do things conditionally, and suddenly the tree shaker can't figure out at build time whether or not a particular function will actually be used.
Yep.
And so we've done that a lot with Ivy, and we think that the mechanism that we've come up with will actually apply to other Angular library authors as well. So we can guide them in the right direction to really help the ecosystem generate these nicely splittable libraries.
And I suppose it's like the typical advice I think many times you hear is just create a very good API, shallow, like a small API, not many public members, all the typical good OO stuff.
Yes, yeah.
And that might also help optimization at the same time.
Yeah, absolutely.
Cool, so everybody should just write good code and then we're all done.
Well, I mean, yes, but it's really on us as framework authors to have good examples and have good guidelines and make it much easier for application developers and for library authors to know what is good code.
Yep.
And to get feedback on that. So they, one thing we're adding to the CLI is bundle budgets, I think.
Oh yeah,
where you can actually set limitations on how big you want your bundles to be. And a lot of developers actually don't look at this unless we surface it in the tooling. They're just, they have too many other concerns to be worried about, like how
rising functionality.
Yes, exactly.
Yeah, and unless you have a problem with performance, many people just don't look in their dev tools, right?
Yes, exactly.
Except many people have performance problems, so they have to do it. But
yeah, that's another reason why we're focusing on debugging in Ivy. So the way the view engine works, it generates data structures which are interpreted at runtime. And that makes it virtually impossible to kind of stop your Angular application in the middle of rendering a template or in the middle of executing change detection and figure out what's going on to actually see into the state of the system.
Yep.
Which it really complicates life for developers. So Ivy is designed to be eminently debuggable. You can put breakpoints in your HTML templates, and through source maps we figure out where to stop in change detection.
Ah, cool. Yep.
That's awesome to actually see on stage.
And is it also going to be like fast to build? Because many people complain about the build time and memory usage and stuff like that.
So in Angular, in both of the renders that we've had in the past, we've had global compilation. And global compilation means that we're building all of your libraries and all of your application code kind of at the very end as this single global step. In Ivy, we're moving to incremental compilation where libraries are already compiled. And all we do is look at the DTS metadata, like any other TypeScript application, to figure out how to compile the application. And so application builds should be cut down tremendously, especially for very large apps with lots of dependencies.
Yeah, I'm on one of those, so I'm really looking forward to that.
Yes, yeah.
Cool. Thank you. Keep up the
Of
good
course.
work.
Thank you very much.
Waiting for Ivy, but it's done when it's done, right?
I'll get back to work on it.
Cool. Thank you all for watching.
You.
Watch this talk. It's on YouTube as well. Enjoy the conference.
Bye.